MIA-PSM and MIPHA. His areas of interest are medical education concepts, health economics, promoting research attitude among UG and PG students.
Use SPSS. There are many softwares which we use in our day-to-day life purpose to either for our dissertation or to publish. So we need to have a result. Okay, so how to go about doing the analysis? Okay, fine. Okay, so the thing is there are a lot of softwares available in the market. These are the common softwares which we use in our software, open source. SPSS, commonly used mostly as an introduction software. And then Stata and SAS, these two are the advanced softwares. Advanced is even a single entry you make, you want to just modify the data, a particular entry in the spreadsheet, that will be in clinical trials. Managing that particular data matters a lot. So So SPSS is a basic version. It's a kind of intermediate software. Excel is kind of basic. So let us see what we can do. Okay, I think around 5-6 of you are having the data which I gave for analysis. I entered data about name, age, gender, weight and height. Okay, some basic things. I'll just tell you how to import this particular data into the SPSS. What are the do's and don'ts in getting it done, and as well as how to go about doing the basic analysis. So one of the main things, mistakes what we do when we start doing research, like in Excel chart, initially instead of having a single line for the name of characters, we will put it as a particular table. Whatever we want to get as results, like a particular title will be given, then some subdivisions, then further subdivision. That is how people do the entry. That is how they do it in the Excel chart. Okay, many of faculty will agree with that. That is how we enter it in the Excel. This is a strict no. Okay, the basic thing is the SPSS software. If you have to transfer the data from Excel to the SPSS, it will recognize only the first line as the variable name, first line as a variable name. And there also we should not put something like name of the patient or name of the individual, age of the person, something like that, weight in kilograms, height in centimeters, like that we should not type. Okay, that is also a strict no-no. I will tell you where to enter those things also. So in some case, or use only underscore as a specific special character. Do not use any other special character. So use only underscore. Okay, use only. So use only the underscore for special character. Do not use hashtag and other things. Use alphanumeric ones like serial number 12 or 11 or name 11, something like that. Okay, data, timing, without any full stop or anything. Only use underscore without any space, just like our mail IDs we create without any space. You create a title. Okay, this is one mistake, common mistake what people do. They will have the software, both SPSS and Excel, they will enter the data. They don't know how to export it to the SPSS. So I have modified and entered like this. So how to go about importing it into the SPSS software. So those people who have installed, just open your IBM SPSS software, the 25th version, whichever is there. Okay. I will go to File, Import Data, and it does give all the options, what type of this thing. So I am clicking here as Excel. Okay. So go to desktop. the Excel is here. I'm just opening it. See, you can see here, it will ask, shall I take it the first line as a variable name? You can see here. It is asking about what type of variable it is. So it is taking that first line as a variable name. So if you have entered the second, third lines also in a spreadsheet with names and other things, it won't recognize that. So it will always create error while importing the data. So in Excel itself, we have to clean the data in such a way that it's easy for us to import to SPSS. So now I have imported it to the SPSS software. Okay, so here you can see here the first line in Excel has become the variable name. So the serial number starts from the second line, 1, 2, 3. So unlike in SPSS, unlike in Excel, SPSS shows a separate line for serial number of data, the number of variables or individual test characteristics, whatever you have, and then the variable name separately. So Excel has only a single page, but wherein in SPSS it does have a separate variable view, wherein it gives us a lot of details about what we can do. Like for example, name. It is a string variable, nominal. It's a peculiar thing. We can't classify it in the type of data like ordinal or numerical like that. So it's a string variable, and here label is given, wherein you can just type name of the patient, everything. Okay. So instead of putting it in the actual variable name in the Excel, you can type all the labels here. Okay. Then gender. Okay, age is a particular number, and the measures, the last one here, the measures, that is more important. It gives both nominal, ordinal and scales. So you can see here scale, ordinal, nominal. These are the three variants based on which our analysis is. Okay, the types of data, whatever the types of tests which was discussed by most of the faculty here will come within these three categories. So you have to classify it in such a way that either it is scale, ordinal or nominal. Age is a scale, 1, 2, 3 like that in years. So if it is ordinal, let's say in BMI scale we have underweight category, then normal, and then obese like that. So it is in some order. We can put it as 1, 2, 3. So similar to that, we can make the changes here. Okay, so sorry. This is one common mistake which we make. Okay, it's quite sensitive, the software. So now variable changes you have made. Okay, like gender, I have put 1, 2, 1, 2 like that instead of male or female. So what I can do here is in gender, I can give the values. 1 is male and 2 as female. Add here. So that will enter. If you enter the values exactly, when you get the analysis output, it will show up as male and female instead of 1 and 2. So you need not go back and check whether what is 1, what is 2 like that. Though it's always better for us to have notebooks by the side for us to have the data coding and other things. Okay, whatever we do on a daily basis, please put it on writing that I have done this analysis, this new variable I have done, combining these two or subtracting this two or using this particular formula like that. Okay, so always have a data coding notebook with you, along with you when you do your analysis, so that on that particular date I created this particular new variable using these two. For example, we have both weight and height here, height in meters and weight in kilograms. So I would like to create a new variable. Okay, the basic thing, we want to transform it into BMI, the common thing. So you have to go to transform. These are the two things which we use on a day-to-day basis, transform and analyze. Transform, first is this computing one, Then this date and time wizard for the date of birth entry or enrollment or the date of getting the particular medicine. If you want to just give the exact days or years in years, months or days, you can use this date and time wizard. So let us compute a new variable called BMI. So my target variable is BMI. Okay. So how to go about doing it? The formula is weight divided by height in meter square. Okay. So how to go about doing it? So it has a numerical expression window here, wherein first I will use weight. We have the weight in kilograms. If it is in grams, convert it into kilograms as a new variable and then go for it. So that also you can do with the same computing one. So divided by, I am putting a bracket. Okay, height is already in meters, so height multiplied by again height for square. Okay, so I have executed my command, so it gives all the syntax of what I am doing in that output window. Okay, there are three windows: this data view, variable view, and this output. So here it is created. Now you can see here a new variable has been created and it has calculated and given. Yes? Fine. So this is how it is done. So it's a basic computing variable. Then in transform we have other things also, like recoding into different variables. Okay, the same thing divided into 2. Okay, I can divide a same category into 2. Okay, like I want to give a cutoff of 1.5 centimeters as for a start stature, or 1.45 meters as a 1.45 meters or 1.5 meters as a short stature. So I can divide into 2 categories. I can categorize this height variable into a different one. Let's say I will use height. I have to use old and new variables. You can see here it gives a range from the lowest to, let's say I'm taking the cutoff as 1.45 meters. So 1.45. Okay, as value as 1. I'll add it up. Then ranging from 1.46 to the highest as 2. Add, continue. Okay, so I have to give an output variable name. So I'll put it as short. Okay. Okay, put change. The icon will come for getting the test. So it's getting executed, recoding the whole into a different variable. Once you go to this particular variable, it does give a particular sort stature. Okay, and it usually goes for decimal. You can correct it here in the decimals. You can just reduce it to 0, and it is a nominal one because it is a 2 categories we have. It's a kind of category, so it's easy to compute, use a new variable or divide the particular variable. In fact, it has a command for just blocking a particular group also. We can, let's say we have 100 males and 100 females in that particular group. I want to do analysis only among a particular group of females alone. I can block all the males using a command. One will be blocked, the other numbers only will be seen, and then you can go for the analysis. So these are the types of basic things which we can get done using the software. Okay, so this is a kind of basic assessment. So one thing is here, if you see any changes, let's say I'm going to make a change here. Okay, any data entry, if I make a change, it will accept SPSS. But whereas in what date and time it was changed. So that is how they find out all the manipulations. And they will ask us to submit the data now and then. Okay, whenever they ask the data, we have to submit immediately for results. Whatever was described, you can see here the descriptive statistics. Okay, here we'll get the frequencies, the cross tabs for our to do table and further analysis. Okay, the plots, the compare means where you can compare the t-test, independent t-test, paired t-test and one-way ANOVA. Non-parametric test, independent sample t-test and then related one or the non-parametric ones. And then we have a graphs builder also, where we can get a particular graph done. What type of graph we want. Usually many times visually appealing graphs could be got from Excel itself. Whereas when you want a particular specific graph wherein we have a scientific value also coming from that particular data, we can use it. I'll just close this. I'll show you how a particular graph is given. Data of correlation, where we usually use scatter plot to check whether there is any correlation first before going for analysis. I'll just show you about the graph. I'm not going into the in-depth analysis of correlation. Okay, for some around 109 individuals, we have the waist and adipose tissue value in the abdominal area. Okay, some basic data and the serial number is given. These three lines are given. These two are continuous variables. So we are given this particular account in the variable. Okay, scale is given. It's a continuous variable. So graph, scatter plot. You can see here bar, line, area, pie, scatter plot, histogram. Everything is there. So I'm going for scatter plot. So it is asking what do you want to put in the y-axis, what do you want to put in the waist, y-axis. So I am putting waist in the x-axis. You can just drag and drop it. And y-axis I am putting adipose tissue. Okay, I am giving it. It does generate a graph. You can see here it has generated a graph. This also you will get it in your Excel also to a certain extent. But in SPSS, if you double click on that any graph which is generated in SPSS, if you double click, it will show this chart editor window where you can do lot of further work. Fine, I want to find the R square value. I'm just clicking the icon here. Okay, a linear one. Okay, it has applied. It is showing a R square linear value of 0.67. So around 67% correlation between the adipose tissue and the waist circumference. If waist circumference is higher, the adipose tissue within the abdominal cavity also will be higher in our ultrasound. So that is how it goes. Okay, you can modify it with colors and other things in this graph editor itself. And you can just copy, paste it in your Word document. Okay. You need not and any output, this output window is important. Many times I have seen a lot of postgraduates coming and asking, sir, I took the output but I have forgot to save it. I just copied from that and then forgot to save it. Whenever you do output, do not delete everything, just save the output with the date. Always keep it along with it. Do not delete anything. Whatever you want, you feel it as important, copy it to your Word document also, but do not, if you have entered it as in class interval. Okay, this is one basic mistake many people do while doing it bivariate. Okay, it always shows both the type of correlation coefficient, Pearson's, which is for parametric data, and then Spearman's for non-parametric, both. You can click both also, but you should always know which test to use. That is the reason why from morning people are talking to you about various type of tests, what to use, what not to use, when to use it. That is the basic crux of statistics. Which test I want to use, that I have to decide first. Otherwise I can click upon everything in analysis, and what will happen is the common term in computer parlance, GIGO. Okay, if your input is garbage, your output also will be garbage in the end. Okay, so what type of output you want? Your data entry should be proper. The type of analysis also should be appropriate for that particular data, whatever you have entered. Then only you will get an appropriate result. Otherwise, your result, everything will be a mismatch. many times you won't get what you are expected to get from that particular result. So always have that in mind. Okay, in a nutshell, so the alphanumeric only you have to enter, use underscore for any characters. Previously, they used to have, like when I started using SPSS some 15 years back, we had a restriction about only 8 characters, including underscore. Nowadays it is okay, it is allowing us to enter. So previous softwares used to have a lot of restrictions. Now it has improved a lot. Okay, so labeling can be done in SPSS itself. So I reiterate that. And then do not combine age groups, that also I told. So these 3 windows, data view, variable view and output view. Okay, so label you can always do. And transformation of data using compute variable I mentioned, and recoding of a particular variable into different variable, recoding like division we can always do. Okay, and data transformation I explained further. And using date and time wizard you can always mention the type of values you want, like date, month and years, or full month, or any way you want to use, you can have it. Okay, so independent sample t-test, which we use it for compare difference of means between 2 groups. Okay, so I have just taken a data. If you the data whatever people are having, you can just take this particular independent sample t-test in that window. The question is comparing the diameters of 40 lymphocytes from normal individuals and 40 tumor cells, whether any difference is there or not. Our null hypothesis is there is no difference in the diameter between the normal lymphocytes and the tumor cells. Okay. Okay, so when you use this, this is the following data which we have. Independent sample, so you can see the value around 80, for 80 people we have, and till 40 is 1, okay, the normal cells, and the diameter of, in micrometer for the tumor cells is given in 40. So go for this, compare means. Okay, independent sample t-test. The grouping variable is 1 and 2. Okay, you can define the group as 1 and 2 in that. Okay, continue. Options. Okay, not much. Okay, cell diameter is the test variable, the dependent variable. Okay, I am checking it. It immediately gives results. So why I was so far concentrating only on the basic data management is, if your data entry is appropriate, your results are going to be there in seconds. Okay, using the software, it's just a breeze to get the results. But if a data entry itself is wrong, then our output is also going to be wrong. So please be wary of this particular fact. So here you can see here it gives a mean score of diameter of both lymphocyte and tumor cells. Many times I have seen people copying it and then just putting it in their Word document for a dissertation or this thing, or you can just here itself you can modify it, okay, by double clicking on that, just like a chart you can do lot of changes here also. So it is significant. So this data, can you check for frequencies? You can check for frequencies of any type of this thing, any skewness also you can check for normality. I have just shown them to be normal, so I can go for a histogram of this, which will show it just shows a normal distribution of the particular data. Okay, so I can do it for both the variables also together, okay, and or separately also for both the graphs. it just gives a normal distribution. So you can see here the standard deviation is not that great compared to me. Okay, it's not it's higher. So it is okay. It's a normal distribution data. So likewise, you can do for Man-Whitney. So okay, paired t-test next. Okay, so here paired t-test is another parametric test for paired data. So I have a study conducted to determine the weight loss in a group after 12 weeks of intervention for very low calorie diet was given. So whether any change in weight is there or not. So for around 15 individuals, we have the before and after values. How to go about doing it? Again, go to compare means paired sample test, before as variable 1, after as variable 2. Again, it does give the value immediately. Okay, so once you have decided what test to do, that is the beauty of SPSS. You will get the results, but we should know which test I would like to do. Okay, that is the main aspect of the selection. And after that, we have the other formats and other things which we can do. So here, if you see here, we will record the confidence interval or the two-tailed significance which the faculty were describing earlier. Okay, so based on this, I will tell there is always a significant reduction in weight loss among this particular group of individuals after 12 weeks of very low calorie diet. Okay, that is how I will tell the impression or interpretation of my results. I'll just talk about ANOVA, the topic which was allotted. When do you want? Of samples, independent samples. So it's a non-normal distribution. So as I showed you earlier, there are two samples, one group 1 and group 2. I would like to compare here. Just tell, it's a study conducted among subjects of 8 patients with immunodeficiency with normal controls. Okay, I just taken a sample of 8 because anyway there's in 2 into 2 table and all, it will come less than 5 and all. So it is anyways a non-normal distribution. Many times this is how we will land up doing non-parametric tests for postgraduates because the sample size which they are supposed to complete in that 1 year, 1.5 years will be would not be adequate many a times. We might be aiming for a particular parametric test which is quite robust, but many times we'll end up doing a non-parametric test because of sample size. Like let's say I have a sample of 50 to be taken, but I have only 15 in the end. Independent samples. In non-parametric tests, independent sample. These two are different two groups, independent groups. So go for it. Usually it's a new thing. Automatically compare the distribution across groups. That is the way it comes. Okay. Group analysis to be group to be shifted here, and then the values here. Run the test. It's processing, and it does give. Okay, it has run an independent samples Man-Whitney U test on its own. So this is a new function in SPSS. Previously we used to select this is what I want, this is what I want, like that. Whereas nowadays it is giving and it is rejecting the null hypothesis as the value is significant. Okay, so you can just, based on this, you can directly write your results. Okay, it does show that with the independent samples Man-Whitney U test, it was significant, rejecting the hypothesis, telling that there is a significant reduction in CD4 count in the end. Okay, that is how the results will be there. Okay, as the last one, I will go for ANOVA. There are 3 groups, more than 2 groups, wherein we would like to check the continuous data, any difference is there or not. So the hemoglobin level of sickle cell anemia. Okay, difference in hemoglobin levels between sickle cell disease people in 3 groups. Okay, thalassemia on the other 2 sickle cell tribes. So how to go about doing it? So the data is entered and 3 groups. Okay, around 41 individuals in total. Compare means in that. See, ANOVA is a kind of test to check the variance, but it does cover, it's a kind of means variation only. Means and variations are different, but in software it comes under the compare means category only. So do not get confused with that. So I am putting the factors as 3 factors group, hemoglobin levels. This post talk I will come later. Okay. So any difference is there or not? Yes, it does tell there is a significant difference among the 3 groups. But among which 2? That also I have to check. So in ANOVA there is this thing, more than 2 groups. So 3 groups are there. Any difference between 1 and 2 or 1 and 3 or 2 and 3? These 3 groups comes, related groups. So for that what you have to do is, we have to go for a post hoc test in the analysis. So here, based on the equal variances, I will just show you that. Okay, for checking the difference between the groups, which group, among which 2 groups the difference is higher, we have to use post hoc test, and there are around 18 post hoc tests in your SPSS software. Okay, so if the assumption of homogeneity of variance is okay, it means the assumption, then 14 tests are there. I'll let you know what tests are being used commonly, and then the assumption of homogeneity is not met, we have another 4. If you go to SPSS, it usually use Bond-Ferroni correction and Tukey's B correction. Okay, these 2 corrections we will do when our alpha inflation levels is okay and the variance is assumed or accepted. Okay, it will show you. I'll tell you there are Kruskal-Wallis test and other things which we do usually to come to a conclusion and do it. Or if your assumption is not met, you go for Tamhane's T2 and Games-Howell. Games-Howell is the usual thing which you use for small sample sizes. We have 3 groups, but I have around 8 or 9 or 10 people only in each group in all the 3 categories. There is a usual James Howell test which we will use for many times in postgraduate. For postgraduate I have used, for STS also, for UGs I have used and given. So we will use this test if it is not met, to find the significance among the groups, 3 groups or 4 groups or 5 groups, whichever we have. We will go for a post hoc test. Okay, so Bond-Ferroni correction and Tukey's B corrections are the common things which we will use, and then James Howell for a smaller sample size if the assumptions are not met. It's coming. Software as well. In the analysis, again in one-way ANOVA, we put the factor in the group, hemoglobin in the dependence list. There is a separate icon here, okay, which tells about the post hoc tests. Okay, so all the tests are given here. Usually go for Bond-Ferroni and then Tukey's B. If equality of variance is assumed, or go for these two. Okay, so that is how we do the analysis. So you can see here there are three groups given. Compared to the sickle cell, first one, sickle thalassemia and the C-trait, or thalassemia compared to these two. So it does give the variation and any significant difference is there in the hemoglobin levels or not. So we can find among the group also any significant changes, because it will help us to decide if we have 3 treatments or 4 treatments, which is better than what. Okay, we know by doing the ANOVA test there is some difference, significant difference, but amongst which the difference is better. Okay, 2 things are better, so among them which is better, that we have to decide, and that can be done with the post-hoc test. That is the crux of this post-hoc test. It's nothing but a multiple variance we are doing again among the groups. That's it. It's a one way we are doing the variance in a single test as ANOVA, and then seeing the multiple differences, variance among the group, so that we can come to a conclusion among the 3 or 4 or 5 groups of treatment, which one is better. Okay, that is how we do the post-hoc test. So this is how we go about doing the post-hoc test. So I'll just stop here, because other tests, if we go ahead, it will take another 1 hour.